So the speed of the water.
By the way, I was listening to I'm making like out of the recording that I made when Miss PC was here. I'm making like a nice fancy like video because all that lecture time at the beginning it was just like white screen. So I'm putting like quantum mechanics pictures over top, and it's pretty neat. But for some reason, my my voice went up like an entire octave when Miss PC was here.
What?
I never like. I was like, "Oh my God, this is quantum mechanics." It was. I was listening to it, just giggling. Like I was speaking a mile a minute.
You were smiling a lot more than you did before.
Yeah.
A lot.
Well, no, that was quantum mechanics gets me excited. I mean, that's but. My voice was so high during that.
Quantum mechanics.
Oh, come on.
Oh man.
Let's try this again. This seemed to work last time.
Especially what? Yeah, like how you get pressure from it. So so what it is it's area times height. So that is going to be volume over time.
Nope, still not.
Area times distance.
That's okay.
Yeah, that's my place. That's my.
Okay, guys, listen up. Listen up. So yesterday we saw that the momentum. Okay, this was from Einstein. Right, momentum is Planck's constant divided by wavelength. So, de Broglie, super famous guy. All he did was this. If I do a quick cross multiplication, then I can say that an object has a wavelength equal to Planck's constant divided by its momentum.
What?
Right? And he got super famous from that.
All he did was
Doing a
switch
cross
the variables.
multiplication. Now I'm kind of putting it down too much. There was actually a lot of experimental evidence to go along with that, but
But all he did was switch the variables. It
That's
couldn't
right.
be that difficult.
Can we do that? You can take some. Make the V-shape. You can make the V-shape constant by dividing.
Yeah, that's
that's exactly right. But the difference is now, what he did was say that it's not just light that has a wavelength. That's the big, de Broglie extension to this. He said, well, maybe any particle can have a wavelength. And it's true. It's been proven with the double slit experiment proves it with light. Obviously, it's a pretty easy one to do. But there's also the double slit experiment with electrons. Double slit experiment with oxygen. Alpha particles, helium nuclei. And they've done it up to the size of buckyballs, which are the 60 carbon in a soccer ball design, which are kind of neat.
Yep.
Yeah. Off Buckminster Fuller.
Yeah.
So it's true that macroscopic molecules, and we're talking, we don't usually assign the word macroscopic to molecules, but compared to photons and electrons, molecules are massive. They've been proven to have these wave-like properties where they exist not just in a solid or a particle form, but they can display wave interference when put through a double slit, which is crazy. Which means technically that any larger particle, it gets harder to make the experiments for larger and larger particles. So it's going to be a while before we're taking Josh and shooting him through a double slit, and trying to see if he interferes with himself. We might be able to.
One day.
One day. Yep, there he goes.
It's so gonna be negative math as well.
Um,
Yeah.
Okay, so this is the difference. This is Planck's constant.
Yeah, I know, right?
No.
I'm listening to the Lord of the Rings soundtrack.
Even I do.
No, I know what part of the film where I don't know, I hear the music and like
Is that the Lord of the Rings stuff?
no. Like I'm just
So the momentum with Einstein's extensions from the photoelectric effect just had to deal with momentum of photons, but now de Broglie is saying that now any Newtonian momentum should work for wavelength. All right, example 2. What's the de Broglie wavelength of an electron that's accelerated through a 1200 volt potential difference? That's a tricky one. This is an actual IB question. So we're going to attack this from an energy conservation standpoint. Okay, so the two energies, you guys tell me, what two energies do you think we're going to be equivalating? What's the new word?
Equivalating. The energy of a photon.
Where do you see a photon? No
Oh,
photon.
sorry, an electron.
Okay, what type of energy?
No. Yeah, electrical potential? Okay.
Yeah, voltage, electrical
Sure.
potential.
Sorry, I'm sort of.
No, that's all right. And then what happens when we shoot an electron through the electric potential? What type of energy does it gain?
Kinetic.
Yeah, good.
It sounds like history movie, like.
And I think a science class is going to be watching the history of this. They're watching Princess Bride.
Okay.
Oh crap.
Now, as an aside, okay, let's just do a little side calculation here.
Wait, he's. Oh, yeah.
All right. So where's momentum in that?
It's the MV.
That's right. Okay. So it's PV over 2. We've never actually explicitly stated that relationship before, but it's pretty straightforward. So EK, we're going to call it PV over 2. We never needed to relate kinetic energy to momentum before, but now we have to. Now yesterday we did that same type of thing with E equals mc squared. This half, when I taught this last year, this half came up and it bugged the hell out of me until I researched it for a long time. And I can explain now, and this is the next note of next page of this note. I'm explaining when you use E equals mc squared versus EK equals 1/2 mv squared. Okay, it's a pretty definite delineation between the two of them. Okay, and then the potential energy on the left-hand side of the equation, it's just the charge times the voltage. Okay, remember that? EP equals just charge times voltage. And in this case, the charge is the elementary charge. Make sure you have a big V for voltage and a little v for velocity.
Are we done putting the lines above the variables now?
Are we done putting the lines above the variables?
Yeah, like for vectors.
Oh, for vector, yeah, for the most part. Yeah. Unless you're dealing in more than one dimension. We're not dealing in more than one dimension.
Yeah. But we still have to put it on for paper 2's on exams. That's right.
Yeah. All right, so let's rearrange this. Nick, come on. You're up. Let's rearrange this for momentum.
Okay.
So fill in the other side of this equation.
You mean V over Z?
Yes.
Which beat?